Hi friends, once again welcome back in our educational channel, that is SYJC Electronics. Friends, in this video lecture we are going to study the next type of shift register, and obviously it is left shift register. In last lecture we had studied right shift register. So in this we are going to study left shift register. What is shift register? A register in which data is applied in serial form and it is also retrieved in serial form. And there are two types of shift registers: right shift and left shift register. Now the logic diagram of left shift register is going to display on your screen. So once again, in this shift registers, the 4D flip-flops are used, and all these 4D flip-flops are negative edge trigger D flip-flop, because in this case, once again, the bubble indicates it is a negative and a triangle indicates it is an edge trigger. So it is negative edge trigger D flip-flop. So all flip-flops are clocked simultaneously because clock pulse is applied to clock input terminal of all flip-flops at a time. Then the reset pulse or clear pulse is used, and this pulse is used to make the flip-flops reset. So at the initial stage, the output of register may be 0, 0, 0, 0. So all flip-flops are in reset mode or in clear mode. Now the input pulse, the input data, that is, once again the same data is there, that is 1101. In right shift the same data is applied, that is 1101. In this case also the 110 is our data, that is a bits applied to the input terminals, and that input, that is a data is applied to input terminal of first flip-flop, that is D0 terminal. The output of first flip-flop, that is Q0, drives the data input of second. So Q0 drives D1. Output of second, that is Q1, drives the data input of third, that is D1, and so on. So in this case, the output of one drives the second, second drives the third, third drives the fourth, and so on. That's why it's known as a shift register. And once again, in this case, data is moving toward the left hand side. That's why it is known as a left shift register. Now, how that data is shifted? Once again, before applying data input, before applying any clock pulse, all the flip-flops are at reset mode. So output of register is 0, 0, 0, 0. Now data, that is 1101, is applied to the input terminal of first. So at the end of the first clock pulse, at the negative edge of the first clock pulse, the bit, in this case now it is the MSB. In case of right shift, the LSB is shifted in the first flip-flop. But friends, in this case, the MSB from the data, now what is the MSB? That is 1. So that MSB from data is shifted to the first flip-flop, while the bit stored in the first flip-flop shifted to the second, second shifted to the third, third shifted to the fourth, and so on. So at the negative edge of the first clock pulse, the output of flip-flop, output of register is 0, 0, 0, 1. 0, 0, 0, 1. In case of right shift register, at the negative edge of the first clock pulse, the output of register is 1, 0, 0, 0. Friends, in both these cases, the same data is applied, but at the negative edge of the first clock pulse, the output of right shift is 1, 0, 0, 0, while in case of left shift, it is 0, 0, 0. Next, when the next pulse applied, at the negative edge of the second clock pulse, once again the bit stored in the first flip-flop is shifted to the second, while the next bit from the data is shifted to the first flip-flop. So the next bit from data is 1, because the inputs are 1101. The second MSB, the first MSB, that is 1, the second MSB is 1, the next bit is 0. So that next bit, that is 1, is shifted to the first flip-flop. The bit stored in the first flip-flop is shifted to the second bit or bit stored in the second flip-flop second flip flop is shifted to the third, bit stored to the third is shifted to the fourth. Means at the second clock pulse, at the negative of the second clock pulse, the output of register is now 0 0 1 1. 0 0 1 1. Next, at the negative of the third clock pulse, once again the bit from the next bit from the data is shifted to the first flip flop, and in this case that bit is now 0. Bit stored in the first flip flop shifted to the second, bit stored in the second shifted to the third, and so on. So at the negative edge of the third clock pulse, the output of register is now 0 at the end of the second clock pulse. The bit stored is 0 0 1 1. At the end of the third clock pulse, the bit stored, the output of register is now 0 1 1 0. At the end of first clock pulse, what is the output? Output is 0 0 0 1. At the end of second clock pulse, the output is 0 0 1 1. At the end of the third clock pulse, the output is now 0 1 1 0. That means with every clock pulse, sorry. That means with every clock pulse, the bit from data is shifted to first flip flop. The bit stored in the first flip flop shifted to the second, second shifted to the third, third shifted to the fourth. So this process remains continued, and in this case, the bit moves in left hand side. That's why it is known as left shift register. Bit moves to left hand side in left direction. It is a left shift register. Now the clock diagram of this register is going to be displayed on your screen. The clock pulses are there. Then the data input, that is 1 1 0 is applied. At the end of the first clock pulse, at the negative of the first clock pulse, the bit from the data is shifted to the first flip flop. So output of first flip flop now goes to high level. The bit in the first flip flop shifted to the second, second shifted to the third. So at the end of the first clock pulse, the output is now 0 0 0 1. In this case, Q0 is at bottom place. Q3, because Q3 delivers the output. So Q3, Q2, Q1, Q0. So in this case, the output is 0 0 0 1. With next clock pulse, the negative of the next clock pulse, the next bit from the data is shifted in the first flip flop, the bit stored in the first flip flop shifted to the next flip flop, and so on. So in this clock diagram, the waveform indicates that outputs are now 0 0 1 1 and so on. So this clock diagram gives how the bit shifted or indicates how the bit shifted in left hand side direction. Next, the truth table. From this truth table, it is clear that now in right shift register, the clock input is given at the first column, then data input Q0, Q1, Q2, Q3, etc. In this case, in first column it is a Q3, next Q2, Q1, Q0, data and clock. Because in this case, the bits are moving toward the left hand side. So at the first clock pulse, before applying any clock pulse, the all flip flops are made clear. So the output is now 0 0 0. So before applying any clock pulse, the output of register is 0 0 0 0. When first clock pulse applies, at the end of the first clock pulse, negative edge of the first clock pulse, the bit, that is the data or bit, is shifted in the first flip flop, that is 1. 1 is moving towards the first flip flop, while the bit already stored in the first flip flop moves toward the next flip flop, and so on. At the negative edge of the second clock pulse, the next bit, that is 1, is shifted to the first flip flop. The bit stored in the first flip flop moves toward the next flip flop, and so on. So in this case also, the direction of arrow indicates how the bits are moving toward the left hand side direction. So that is left shift register, in which the bits or data are moving toward the left hand side. So that is our registers. Right shift register, in which data moves toward the right hand side. In left shift register, in which data moves in left hand side direction. So friends, thanks for watching this video lecture. In next video lecture, we are going to start our new topic, that is counters. How the flip-flops are used to measure the frequency of our input clock pulse. It is used to count the number of pulses applied to the flip-flops. That's what is known as a counter. In our next lecture, we are going to study the counter, the types of counter. So friends, once again, thanks for watching this video lecture. Bye. Take care. See you again.